One of the greatest scientific missions of modern times has taken a giant leap forward today with the launch at lunchtime of the James Webb Space Telescope.
The James Webb Space Telescope has just unveiled its most groundbreaking achievement to date, the first ever real image of another world beyond our solar system. This moment marks a turning point in the history of space exploration and planetary science, offering humanity an unprecedented glimpse into the mysteries of distant planetary systems. The image, captured in stunning detail by the telescope's near-infrared instruments, reveals a planet orbiting a star hundreds of light years away. An exoplanet not imagined through artists' impressions or speculative graphics, but seen as it truly is, with colors, atmospheric composition, and even hints of cloud formations suggested by light scattering patterns. Before we start, smash the like and subscribe buttons for more updates. Positioned nearly 1 million miles from Earth at the second Lagrange point, the James Webb Space Telescope is equipped with instruments sensitive enough to detect the faintest glimmers of infrared light coming from objects that have eluded direct observation for decades. This new planetary image is a milestone not just for its aesthetic beauty, but for what it represents. The culmination of decades of technological advancement, human collaboration, and an insatiable curiosity about our place in the cosmos. Unlike previous exoplanet discoveries, which relied primarily on indirect methods like transit photometry or radial velocity, this is a direct capture, an optical window into a foreign world. What sets this particular observation apart is the clarity and fidelity of the data. The planet imaged by Webb is a gas giant, many times the mass of Jupiter, orbiting a relatively young star that is itself still shrouded in a faint nebular haze. This setting provides a natural contrast that made direct imaging possible. Using its coronagraph, a specialized device that blocks out the overwhelming glare of the parent star, Webb was able to isolate the dim glow of the planet itself. The result is a sharply resolved image that reveals not only the planet's presence, but also some of its physical properties, including temperature variations and potential signs of atmospheric dynamics. This revelation instantly expands the frontier of exoplanetary research. For the first time, scientists can study a planet beyond our solar system through direct visual means, allowing them to analyze light that has bounced off the planet's atmosphere. Spectroscopic analysis from the captured image has already provided tantalizing hints of methane, water vapor, and possibly even more complex organic molecules swirling in its upper atmosphere. These are not definitive indicators of life, but they are building blocks of chemistry that could, under different conditions, support it. The implications of this breakthrough are staggering. One of the long-standing limitations of exoplanet studies has been the lack of direct observational data. While thousands of exoplanets have been cataloged through transit dips or gravitational wobbles, these methods only offer partial information, such as size, mass, and orbital distance, but Webb's real image changes the paradigm. It provides a complete spectrum of light from the planet itself, opening the door to understanding surface conditions, weather patterns, and even seasonal shifts. No longer is the study of exoplanets limited to educated guesses. It has entered the age of direct observation. Moreover, this success acts as a technological proof of concept. If Webb can capture such a detailed image of a massive gas giant at this distance, future iterations of space telescopes, perhaps even equipped with star shades or larger mirrors, could do the same for smaller rocky planets, the kind more likely to resemble Earth. The dream of visually confirming an Earth-like exoplanet, possibly with blue oceans and green land masses, suddenly feels less like science fiction and more like a tangible, approaching reality. The image itself, released by NASA in collaboration with the European and Canadian space agencies, has already begun to inspire a new generation of astronomers, engineers, and dreamers. It shows a glowing orb, slightly oblate due to its rapid rotation, with bands of color denoting atmospheric stratification. Subtle auroral effects at the poles suggest the presence of a magnetic field, and slight dimples in the luminosity may point to transient storms or heat distributions. The planet is not just a statistical data point anymore. It has a face, a presence, a place in the story of the universe. This is not the end of discovery, but the beginning of a new observational era. Webb's image offers a starting point for years of follow-up study. Every wavelength of light captured contains layers of information, and researchers are only beginning to decode it. The planet's albedo, or reflectivity, is being analyzed to determine the nature of cloud cover and surface features. Infrared emission tells stories of internal heat and atmospheric circulation. Variability in the light curve over time could indicate rotation speed, axial tilt, and even climate cycles. These are no longer abstract theoretical exercises, they are real data sets flowing in from a telescope over 1 million miles away, turning scientific hypothesis into measurable phenomena. This also marks a new threshold for collaboration across disciplines. Astrobiologists, planetary scientists, climatologists, chemists, and data analysts are converging to study the single image, drawing out every bit of knowledge it contains. For astrobiology in particular, the image holds the promise of assessing a planet's habitability, not just through models, but through direct environmental reading. Understanding the atmospheric pressure, greenhouse gas composition, and temperature gradients could eventually help determine if a planet has conditions conducive to life. While this specific planet may not be hospitable in the way Earth is, given its gaseous nature and extreme temperatures, its successful imaging proves the path forward. It validates the instruments, the mission design, the computational models, and the theoretical frameworks that underpin the search for habitable worlds. Most importantly, it shows that the technology to image Earth-like planets is within reach. As observational methods improve and longer-term campaigns are launched, the ability to detect biosignatures, such as oxygen, ozone, or chlorophyll analogs, comes closer to realization. This achievement also forces a shift in the philosophical narrative of astronomy. For centuries, humans have wondered whether distant worlds exist. That question was answered in the affirmative with the first exoplanet discoveries in the 1990s. The next question, what do those worlds actually look like, has now begun to be answered, vividly and indisputably. This direct observation moves the field from the abstract realm of inference into the concrete domain of visual evidence. It changes the nature of the public's engagement with space science. A picture, especially one this monumental, is not just worth 1,000 words, it is worth 1,000 new ideas. The success of this image also affirms the importance of long-term investment in fundamental science. The James Webb Space Telescope was decades in the making, with numerous delays, budget debates, and engineering hurdles. But its ability to deliver a sight no human had ever seen before, a real view of a distant world, is a profound testament to the power of sustained curiosity and coordinated effort. The payoff is not just scientific, it is cultural and civilizational. It expands the human story to include not just our planet or our solar system, but our growing neighborhood in the galaxy. Already, the implications are being discussed in mission planning rooms and research labs around the world. Observatories on Earth will now use Webb's image as a reference point to calibrate their own data. Plans for next-generation telescopes, such as the Habitable Worlds Observatory or LUVOIR, are gaining fresh momentum. The demand for clearer, closer images of rocky, temperate exoplanets will only increase, and so will the drive to explore them. Perhaps one day not just with photons, but with robotic probes or interstellar craft. For educators, this image offers a new tool to ignite passion in young minds. It is no longer necessary to rely on artists' impressions when teaching about exoplanets. Now there is a real-world example, a tangible, observable body orbiting a distant star. Seen with instruments so sensitive and precise they can decipher atmospheric makeup from light years away. It becomes easier to teach about spectroscopy, orbital mechanics, and planetary physics when the examples aren't theoretical but photographic. For the general public, the image stirs something deeper, an emotional resonance, a sense of awe, a rekindling of humanity's most ancient instinct, to look up and wonder. The knowledge that such worlds not only exist but can now be seen in all their alien beauty is something that transcends scientific jargon. It becomes part of the shared human experience. Just as early photographs of Earth from space shifted our understanding of our own planet, this image of another world may do the same on a cosmic scale. From a strategic perspective, this milestone strengthens the case for continued international cooperation in space. The James Webb Space Telescope is a model of what can be achieved when nations pool resources, expertise, and vision toward a common goal. Future missions will likely require even more collaboration, combining optical telescopes, radio arrays, gravitational wave detectors, and perhaps even planetary landers launched across interstellar distances. The foundation has been laid, and this first image stands as a symbol of what is possible when humanity reaches for the stars with clarity and purpose. Beyond the scientific and technological ramifications, the image challenges philosophical frameworks as well. It forces a reevaluation of how we define worlds, life, and our place in the universe. When looking at the glowing orb captured by Webb, one must ask, what stories unfold beneath those clouds? What weather systems rage there? What forces shaped its formation and evolution? The same questions that we have long asked about our own planet now extend outward, to planets that are no longer points of light but visible, photographable places. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on the James Webb's first real image of another world? We want to hear from you. Thank you for watching, and see you next time.